Okay, in this exam question, I'm going to help you answer a question that asks you to explain how GLEY soil is formed, with specific reference to climate, relief and drainage, as well as other factors that create the GLEY soils. What I'd recommend you first do is watch the video that teaches you how to draw and annotate a diagram on the characteristics of a GLEY soil, because that exam question gives you the basic breakdown of the soil, and it's from that which you're going to then look to explain how the GLEY soil forms. But if we actually have a look at the exam question you're being likely to answer, it's going to be explain how factors such as natural vegetation, soil organisms, climate, relief and drainage have contributed to the formation and characteristics of the GLEY. It's what I would call one of the heart of the physical environment exam questions, because you're being asked to explain how these soils form rather than just drawing diagrams and annotating them with descriptive labels. These questions could be worth 8 and even potentially 10 marks, so you have to be prepared with lots of points of explanation. Right, let's take a little look at the GLEY soil, which you will have hopefully studied when you looked at the previous question that asks you to draw and annotate a GLEY soil. And here you can see the typical A, B and C horizons. When you're thinking about any soil, you have to remember that a soil forms on what we call the parent material, on the rock. And if we go back thousands of years, there would have been a point in time at the end of the last ice age when there would have been no soil, there would have been no A and B horizon, simply the parent rock, which has now begun to get weathered and broken down by natural processes like freeze-thaw and chemical weathering. And gradually, as that rock breaks down, that releases minerals, and along with sunlight, the soils begin to form, and they develop deeper and deeper over thousands of years. So that's the process we're thinking about. And if we talk about the GLEY in general, the GLEY is one of the poorest quality soils you find in the world. It's obviously associated with Scottish bogs and upland mountainous areas that are very wet. It's pretty infertile. Farmers don't typically use it for anything other than rough grazing at best. Okay, so what I need you to be able to do is probably be able to draw this diagram to answer the first of the possible exam questions, which is draw and annotating. And then once you've learned that diagram, look to be able to explain each of these points. Okay, and that's what I'm going to do with you now, step by step. And after each step, I would suggest you pause it, note down the point of explanation, along with the point of description, and look to build sort of 5 or 6 of these into a good answer. Okay, so the first thing you're going to want to say is that these soils form on poorly weathered parent material, and then you can say which results in the soil being very poor in mineral content. So that would be poorly weathered parent material as a description, and then explaining that this then results in the soil having poor amount of minerals would be the explanation of how it contributes to the soil. Sticking with the parent layer, we could then go a little bit further and say the soil also forms often on clay, which will stop the downward percolation of water, because water would be percolating downwards, will be leaching downwards, and when it gets to the rock layer, it would either percolate into the rock, or if it was impermeable, then it wouldn't. Well, because clay is impermeable, it cannot percolate into that rock. So that's the first thing you'd want to say, that it forms on clay, which stops percolation of water downward. Now, to explain that, you would then say which results in the soil becoming waterlogged, because the water can't percolate into the sea layer. Okay, so there's your second point. Now, if we move on to some other points you can talk about, you can say that the soil is also going to be very waterlogged because it's found in very wet climates, like the mountainous areas or river floodplains or at the bottom of the slopes, meaning that there's a huge amount of water building up in the soil all the time. And because it's also a cold climate, there's going to be very little evaporation of water out of the soil. Another point you can make is that the soil is poorly mixed. And you then want to explain that, and you would say that's because of a lack of soil biota, for example, worms. Okay. Developing this idea into another point, you could say the soil lacks biota, and now you want to explain why it lacks biota, and you'd say because it's found in very cold climates, so therefore it's difficult for organisms to survive. And also because it's waterlogged, this creates anaerobic conditions, which means that there's very little oxygen in the soil, and therefore soil organisms, or biota, which is a better word to use, cannot survive. Okay. The top layer, the O horizon, is very dark, and it's an acidic moor humus, that's M-O-R. To explain that, you'd say that's because there's a very thin natural layer of vegetation like mosses and lichens, which is why it becomes very dark and acidic. You can also make a point here of saying that because there is a very poor vegetation layer on the surface, it results in the soil being very nutrient poor because there's very little nutrients being leached downwards because the organic layer is very poor in nutrients. Okay, a few other points. The soil tends to be very thin. It's not very deep. And you would then say this is because it develops in very cold climates where there's limited natural vegetation growing, which would have otherwise fed the soil. But because it's very cold, very little grows on the surface, and therefore the soil takes a long time to develop. Finally, you can tell me that heavy rainfall leaches the upper layers, the horizon, giving it a sort of dark grayish color, and the iron compounds present in the soil get mainly leached down to the B layer, and then they oxidize, which is the same as rusting, which is why the B horizon often has a kind of reddish, mottled look. That's this kind of speckly red look, if you were to dig into it. Okay, so we've covered a whole series of explanations, and if you rewind this, or if you've been pausing this, hopefully you've been able to separate each one into both a description of a point, like it's red and mottled because there's a silty texture. I haven't actually mentioned that. It's a silty texture because there's a high amount of clay in the soil. There's very little soil biota because there's anaerobic conditions created by waterlogging. That's the approach you want to take, always identifying a part of it and then explaining. So that's why it's useful to learn the first part, which is how to draw the diagram and annotate it with the descriptions, and then learn a second answer, which explains the descriptions. You do also get marks for descriptive points in a question like this. So if you're describing a point and then explaining it, you'll get credit for 2 descriptive points. We'll get you a mark. And then every time you offer an explanation, you'll get a further mark on top of that.